Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about digital transformation in 2022 with special guests Gretchen Stewart and Dr. Anna Scott. Gretchen and Anna, welcome to the show.
Thank you. We're delighted to be here.
Hey, Gretchen is our chief data scientist in public sector at Intel. And Gretchen, tell us a little bit about yourself, about your background.
All right. Well, thank you. Again, delighted to be here and can't wait to have this be one of a series. And we are going to talk about digital transformation. As the chief data scientist in our public sector, it means I spend my day talking to customers about data challenges they have, data management, data governance, what's the ethics around what they're doing, responsible AI, and every once in a while, I even put finger to keyboard, but I have to admit, I don't do that as much as I'd like to. But delighted to be part of this because this is going to be an exciting year.
Hey, thank you, Gretchen. And then we have Dr. Anna Scott with us. She is our Chief Edge Architect at Public Sector. Welcome, Anna.
Thank you, Darren. Nice to be here. I've been with Intel about 6 years. The last 3 have been very focused within the public sector, but the whole 6 years have really been around IoT and edge. I think this is hands down the most exciting year for what happens at the edge because there is so much going on with respect to overall architectures and how to really leverage edge compute relative to what can be done in the cloud. What is possible now with comms and the enablement through 5G and things like multi-access edge compute. This is really just a really exciting time. So I'm delighted to have a chance to talk about this in the context of the 6 pillars, especially because I think that framing of edge capabilities and comms capabilities along with the other pillars is really going to change how we can do digital transformation for our customers. And really, it's changing the game on what's possible from a problem solving and a capability standpoint.
So you mentioned 6 pillars. So let's talk about this. The 3 of us came together, and because we all represent different parts of digital transformation with our customers and all that, and we came together to kind of come up with a common deck a common way of talking about digital transformation, and we came up with 6 pillars. So we came up with multi-cloud computing, edge computing, artificial intelligence and machine learning, cybersecurity, data management, and comms. So those are what we think are going to be the big transformational things in the coming years. So we're going to talk about that between the 3 of us today and how Intel is actually, and people don't think of Intel and multi-cloud. They just don't, right? Because we produce chips and software, but what we're finding out is we actually know quite a bit about these 6 areas because we've built hardware and software to support those areas. So, I mean, that's kind of where we sit.
Absolutely, Darren. And to jump on what Anna was saying, artificial intelligence, machine learning, deeper learning are really techniques that people are using. And they have been heightened and exploited and are just growing exponentially based on cloud, based on edge, and the capabilities where you can really take those kinds of models and be able to leverage that data at the edge, infer, take some real actions, keep that data, and then traverse it back to a data center or to a cloud. And security is a key component for all of that. So it's incredibly interwoven, and I'm delighted to be part of this organization that's really going to lead us forward.
So Gretchen, you mentioned, it's all interwoven together. What is Intel providing on this? I mean, because people think of Intel as, hey, silicon manufacturers. So are we providing hardware in all 6 of these areas? What are we providing? What do we do? Anna or Gretchen, either one of you.
Yeah, I'll jump in for a second, but absolutely let Anna jump in. But it's hardware that we're providing. A number of people don't realize that Intel is the underpinning for the majority of the cloud providers. So from a hardware perspective, but we also from a software perspective, you think about common frameworks that people use today from an AI or ML or deep learning perspective. They're talking about CNN, neural nets, PyTorch, TensorFlow. So we've optimized all of those to be able to take best advantage of the hardware underneath. And in some cases, it's 10 to even 100 times better performance based on the software work that we've done.
That's incredible. Anna, what about you?
Yeah, same thing. So when we get into edge and comms, we are definitely providing hardware into those, especially in 5G. 5G, we've got some remarkable capabilities, but we've augmented those not just on hardware. So it's not just hardware. We actually have software reference architectures, and we do things like FlexRAM. We're also really heavily involved in the standards organization, the 3GPP, that's setting what's going to happen with 5G as it goes through its multiple releases. And we're really at just this great position of understanding how hardware can support not just comms, but applications and compute, and then really making sure we've got software that's going to enable that. And since we're Intel, right, we are really trying to make these ecosystems work for everybody. So we have a really strong focus on open systems so that this is done in a non-proprietary way that really makes it easy for not, new entrants or for existing players to have a very expanded footprint in these new markets. And so there's just a lot of exciting stuff that's happening. I want to do a little bit of a plug for our security features, because one of the other things that's just implicit with how we're doing our hardware design is making sure we've got capabilities that are embedded within the silicon that can support the security functionality that we need in this vastly complicated world. And especially moving things to the edge, we've increased our attack surface to just a staggering extent. And so having ways to ground security in a hardware root of trust just becomes more important every single day. And so we've got those along with a whole other slew of features that allow us to really make sure that our customers in the ecosystem can protect their data in all of its different permutations.
So, and I'm glad you brought up, and Gretchen, both the software and the hardware stack. We also are incredible at building ecosystems. And this is where our work and providing solutions to customers, right? And that's the combination of the hardware and software and systems integration. And we actually have a really great relationship with most of the systems integrators, especially in the public sector space, where we're teaching them how to leverage our software and hardware more effectively to provide solutions both at the edge, in the data center, and also in the cloud. So it's really, and people don't know that about Intel, that we can actually do all those things.
Yeah, true. I think that's absolutely true, Darren. And
Yeah.
Anna touched on open source, which is really important. I don't think a lot of people realize that Intel is one of the number one contributors, if not the number one contributor to the open source software community. And that can be at the low level of firmware and frameworks and libraries, but it also can be at the higher level with a lot of the no code, low code things that our citizens data scientists are really trying to do today, where you don't have to have a PhD in data science, that we've tried to make it simpler and extract a lot of the intrinsics that you need to know about from a hardware perspective. But if you're running things bare metal and you want to run it in a container, that we absolutely ensure that those software layers that you're leveraging have, to Anna's point, that security built in, the security of understanding, okay, there's a trusted module, there's different instruction sets, things that you need to know from a lower level silicon perspective that are built into those frameworks, into those libraries, and many times into that low code, no code. So it understands all the way down to the hardware level to ensure encryption and ensure safe use of data.
Okay, we're dancing around security. Let's just talk about it. The security pillar that we've talked, it's probably the most prevalent when we talk to people. They're all worried about security. I think COVID has kind of exposed a lot of security holes because people are working remote. We've seen a huge uptick in ransomware the last 18 months. So let's talk about security. Does that sound good?
Sounds great.
Dive right into that. So we've got a great CTO at Intel Federal that talks about security all the time. Each one of us understands security because every time we talk to someone, it comes up. Intel has a unique position in security. So Anna, can you give us a little taste of the different areas that Intel can help provide better security than what is out there today?
Yeah, certainly. And one of my favorite things to say about security now, which is kind of dogma for all of us, right, is security is never static. We know that it's going to be evolving, right? So Intel really focuses in multiple areas, and there are some real strengths that we can bring to the table. But just to make sure it's clear up front, right? Intel alone is not going to solve your security problems. It is very much an interplay with what you do with your hardware, how you bring in the right software elements, what's your real risk profile. How do you plan to, set up your own understanding and in boundaries and policies around what is important for your organization and how to protect your organization? So we do try and understand that we work with lots and lots of different companies and organizations, and they have their own levels of stringency that we apply. So one of the very foundational things that we do is the whole idea of hardware root of trust and how you can do authentication. So we have a lot of features that can be built in directly to do that, so that you can say this device is definitely this device. We get to take it a step further because we do a lot of work with trusted supply chain or transparent supply chain, so that we can share with our customers what's the whole path of allowing us to create our silicon and make it available for use. And we continue that through working with our OEMs as well, so that by the time it actually ends up in your office or data center as a set of compute, you have the information that you need on that to have a high degree of confidence in that. I'll just say that those capabilities are getting better all the time. We've invested a lot into those, but really the amount of scrutiny and the amount of attention being paid to that now is at a level I don't know that we've ever seen before. And so we are constantly going through and trying to improve our capabilities there. So it's always a work in progress. So I don't want to just say, hey, everything's absolutely solved, and you can buy a piece of silicon and we can tell you everything you ever wanted to know about that, because that is definitely true with some of our CPUs, but it's not true with absolutely everything, right? So again, trying to be transparent.
Yeah, I love how you described it as it's a changing.
Oh yeah,
right. I mean, the types of attacks we're seeing, detecting those attacks, different mechanisms, and the edge, and we could probably drop right into the edge pillar too, is actually extending security outside of your data center and outside of the cloud. So now even physical security ends up being a problem.
Definitely something that is top of mind for many of our customers, right? And maybe just to do like a little bit, we've got things like trusted execution and secure enclaves, which is another thing that we do. We have a whole set of capabilities that are meant to allow for you to do the encryption and the type of security you want to do without having huge performance hits. So there's really like a whole matrix that we do of our 30 plus capabilities that we bring to the table. So we don't have time or probably the patience to go through all of those in detail today, but just say there's a lot of things that are out there. But if we go back on the edge side, right, we really do have a different set of requirements on the edge, because when you lose the physical security of the data center, you have to be very cognizant of of what does that mean to protect protect your data, especially if somebody can just like walk in and attach to your network, or can grab your gateway or your industrial PC and take that someplace. We can't allow those to be entry points now that can cause issues for the protection of our customers' data. So that definitely becomes a different way of kind of framing what your boundaries are and talking about how are you really going to secure. There's a huge chain of thought now around zero trust and how to do architectures for zero trust, and that's really becoming the framework that is especially prevalent in the public sector side. But for the DoD, that's really a mandate now, and that to say very, very simply, zero trust is don't trust anything at any time, anywhere, right? So there's not just, hey, you need to know that your device is trustworthy. You want to know that your device is trustworthy at this moment and have the right policies in place so that you can really, continuously check to make sure that something has the right permissions and is allowed. So we do have a lot of capabilities that feed into that, but I don't want to hog all of our time. So I'm going to kind of pause with that one. And
as you guys could tell, we could go.
No,
we could have the whole.
So right. Yeah, and
whole podcast on security, probably a whole bunch of them.
And a big part of it's security around the data. So us, in terms of what we're able to add into some of the frameworks, again, leveraging the underpinnings of what Anna was just talking about, but also really using things like role-based access control and just the identity and access management that's also part of other software companies that we work with. So it's not as Anna said, it's not a one size fits all, but I think one of the things that's becoming abundantly clear for all the customers that we're working with, it's not a bolt on, which it has definitely been in the past. It really needs to be built in from the beginning. And built in from the beginning means that you're continually iterating, you're continually looking at, do we have the right security protocol set up? Do we have the right things in terms of threat detection? If we're not trusting anything or anybody at that particular time, can we also ensure all the way back to the supply chain that the components that Intel or others might be supplying that then are built together, that are then used by a Lockheed or somebody else in our public sector, that we can ensure that those are indeed secure. And all of that is really integral, and yeah, we could spend days talking about it.
So let's shift real quick over to edge. We know security at the edge is a big deal. And back to you, Anna, this is your expertise. What other challenges do you think we're going to see at the edge over the next, or not necessarily challenges, but what opportunities are we going to see at the edge this next year that you think are could really shift things around?
Yeah, so what's gotten really exciting is the idea of now that there's so much that can be done with AI and ML and different algorithms, right? Is how can we really exploit those at the edge, and then how do we optimize architectures to deliver around those use cases, right? So we can do some really simple models where everything lives on the cloud, and what you do at the edge is just do the data gathering, and if your connectivity allows it, then you can actually have the latencies that match your application, and you can just, like I say, have the bulk of the compute be cloud-centric, right? But there's about a gazillion use cases where that makes no sense, where what you really need to say is, because of the sensitivity of the data, or because of the latency requirements, or because the network just doesn't support the types of latencies needed for those use cases, it's like, how can you really get that down to the edge, right? And what does that architecture look like? And on the DoD or on the public sector side, obviously the swap requirements become kind of paramount depending on where that's happening. And so we get a lot of really interesting conversations to say, what's the optimal architecture for the edge, again, based on the use case and what's happening with cloud and network. But then we get really fun things like, hey, we'd love it if we could have like this whole seamless architecture of, you're gathering your data, that data is being used immediately to process it and to provide intelligence and the information desired by the organization. But at the same time, can't we like incorporate that into the next round of training so that that model is continuously being updated, right? And how fast can we really make that loop, and how viable is that? And do we need all of our training on the cloud? And if all the training is on the cloud, then what's the right interval for dropping those updated models back down? How close, and so it just becomes this really fascinating set of decisions and questions. And especially it becomes, okay, how lightweight are you at the edge, and can you be lightweight enough that you can still use this stuff you generated on the cloud, or do you have to start doing some transformations of those algorithms based on what you can really provide at the edge and how much compute at the edge, right, for the inference? So again, it's just that's where it gets super fascinating.
Yeah, so Anna, it sounds to me like the edge is still very complicated.
Absolutely.
There's so many possibilities out there, especially when we talk about our next pillar, which is AI and ML, which, that really enables the edge to do so much more than what we've ever thought of before. So I think that's wonderful. But let's dive right. We got to switch. We can be here for hours. Gretchen, let's talk about the AI ML pillar. This is in your wheelhouse. This is your strength. Tell us a little bit about what you see happening in the next couple of years in the AI ML space.
Well, Anna really set the stage to discuss the fact that it's about fit for purpose. And there's just so many things that are going on at the edge or throughout the entire data journey where, one product, so again, going to Intel's hardware, a CPU is not always the right answer. Neither is a GPU or a video processing unit, a VPU, or the multitude of neuromorphic ideas that people are working on today, including Intel. And the use of open source, I think, is really critical. And being able to take those microservices. So think of it as you don't need the entire operating system, but you need a part of the operating system to be able to run these algorithms at the edge. So you're able to create a microservice, you're able to have those algorithms right at the edge doing real work. So you're talking about traffic flow. Well, we need to change the cadence of red light, green light, yellow light because the traffic is more dense at this time of the day. So we're going to change that. And it can be done on the fly based on how quickly cars are going through, that image recognition to understand, we need to be changing some of this. And that can be done on the fly. And at the same time, collecting that data to pass that back into a larger data center that could then do the retraining that says, okay, by the end of this week, we want to redo, maybe there's some additional microservices we might need to add, and there's some algorithm tweaking that we've done, then we just pass that container back down to the edge, and you're really able to respond even better and continue to learn. And I think that that's just one example, but having open source and the flexibility to be able to have those microservices and algorithms that you're leveraging is one. And the other thing is when you're talking about fit for purpose, you really need to think about the bandwidth and the latency and the form factor. There are customers that we've worked with who are trying to do crop yields as an example. And when they're doing that, they want to collect all that data, but all that data then goes to a data center. They're working on the models, but that doesn't ever go back to, you need some more fertilizer. You've got some challenges with sun and rain for the last few days. So that means you've got to change your formula in a different way. And if you want to take those crop yield data and that information, that algorithm and those microservices, well, you need it in a much smaller form factor. The latency is different, the bandwidth is different, and yet you can have a small little unit in the middle of a crop field collecting that data and responding back to the flow of the water or whatever else you might need to do in terms of fertilizer, et cetera, to help with crop yields. And those are the exciting things that are going on. I think the thing that I am hoping will happen this year, honestly, from the edge is creating a little bit more of a standardization, because Anna knows this better than I do. But when we think about FlexRAN and 5G, there's some standards, which is awesome. But when we think about some of those edge designs, it's a little bit of the wild, wild west. A lot of people are designing very interesting things, but yet they're not designing them in a way that makes it always easy to just have those microservices in a container and the ML and AI kinds of algorithms And in some cases, you need multiple algorithms weighted in a different way, changing every week based on the new data and the new training. And how do you do that in a way that, hey, it doesn't matter if that's a device built by Samsung or a device built by Intel or a device built by somebody else. And the truth is it does. So some of what I'm hoping in 2022 is to create a little bit more of a, not only AI ML data standard, but absolutely standards at the edge, because I think that will really help to explode what the capabilities are.
See, I'm glad you brought that up, because AI and ML, from my perspective, has been a science experiment. I do it once, ooh, it looks really cool and it gives me that, but repeatability and things like that is tough, right? And because
yet it's really critical.
Yeah, there are no standards.
And AI and ML, I mean, people are like, oh my God, this is new, it's going to take my job away, all that kind of stuff. I mean, I have to say to people, and I probably say this way too much, but the first conference dealing with this was in 1956 at Dartmouth College. It was smart mathematicians leveraging National Science Foundation funds to really start to talk about the art of the possible. And the cool thing is the art of the possible is now. And that we've got, as Anna was saying, the capabilities at the edge. We've got 5G. We've got what comes after 5G. We now have that storage, that compute, the capabilities that we did not have in the past to be able to do just what I'm talking about. Not only inference, not only saying, yes, that's a bad guy, or yes, that's a goat in the desert, or yes, that's traffic that's flowing way too fast or not fast enough, to be able to do that. But at the same time, you need to continue to retrain, because the optimal insights change as the data changes. And the more data you get, the better insight you have, the more accuracy you have.
Okay, all right. We can talk, as you guys can tell, we can talk about AI and forever. But you brought up the next pillar, which is comms, right? And this year, I'm hoping, Anna, please tell me it's going to happen. 5G is really going to take off this year. Is that really going to happen?
So I think on the commercial side, absolutely, right? Because the carriers are leading the way with that, and so 5G on your phones, that's going to be everywhere. Right. There is still a lag for having the type of UE or user equipment that we need to do all of the types of applications that we want to do once you get, away from, personal and cellular, and you want to move into edge applications or enterprise applications and things. That is looking very, very robust. So Intel is actually standing up our first 5G networks with our partners that are more cutting edge and less on the commercial side. Obviously, our commercial partners have had stuff going for a long time, but we're really seeing the proliferation of those private networks that are controlled for a specific purpose, and then really starting to see the build out of those for applications. So yes, I think, don't worry, it's definitely this is going to be the year where we start seeing all of that stuff in play in actuality, as opposed to conversations of, hey, this really super cool stuff is coming any day, right?
Yeah,
so I'm excited about that because of the work that we did with some shipyards.
Yes.
And they're always digging up cables because they're moving ships around. I mean,
changes everything. Yeah, 5G is going to change industrial in some really industrial, and well, it's going to change everything. But industrial manufacturing, when you start talking about being able to do wireless comms and bring a lot of your enterprise capabilities, outside or into your actual working environments, the amount of productivity gains that can happen there, and then how you can use that wireless communication to really understand and start, like we've been talking digital twins for forever, right? Yeah. But we're really within line of sight of digital twins being economically feasible, so that you can afford to put in the sensors and do that real-time analysis of that data in a way that is absolutely going to change what we can do at things like shipyards.
I agree. And really what this is all allowing you to do is around the data and the whole data management, and the fact that it used to take quite some time to ingest and prepare and analyze and act on that information. And what all of this is going to be able to do is that used to take days or hours can take minutes or nanoseconds. That you can look at that information, ingest the information, normalize it, integrate it, be able to leverage different models, maybe weight them differently today, and 2 weeks from now, when you've got even more data, the weights might change a little, and that you can really act and consume that data and that information instantaneously, and provide better services for citizens, better information for the warfighter, and really meeting the mission of our customers so much better than we've ever been able to do.
Okay, all you just noticed what Gretchen did. She brought up the next pillar, which is data management. That was sweet. That was very sly.
Thank you. I'm looking for my Venmo money soon, right?
Yeah. So I love how you said that, because I always thought of AI and ML. And we had this debate whether there should be 5 pillars or 6. And the debate came up about, is AI, ML, and data management the same thing? And you and I both agreed. We both said, no, they're not. Because moving data, managing that data, operationalizing your AI and ML is part of what data management brings to the world. And I think that's lovely. Thank you, Gretchen, for just sliding that in. That was beautiful. Okay, we got 1 pillar left, and it's mine. Right? It's the multi-cloud. And when people hear multi-cloud, they go, oh, cloud service providers. No, that's not what multi-cloud is for us. For multi-cloud, we're talking about infrastructure in general and how to abstract that infrastructure away so that I can deploy new capabilities across the edge, across a cloud service provider, or even across your own data center infrastructure. And the goal with the multi-cloud architecture is that we understand who all the key users are of that infrastructure, and more importantly, how the data is managed in that infrastructure. And this ties into data management pillar as well. In fact, if you've noticed, when we've talked about the pillars today, they all intertwine. They all work together. And that's why we decided, the 3 of us, to come together and start talking about these things together more often. So
yeah, absolutely. And Darren, you know this better than anybody. There are different clouds that honestly have a little bit different expertise. And in some cases, hey, if you're doing natural language processing and you've got a particular use case, a product like Habana on AWS might be the best place for you to go. But if you're looking at doing maybe some object detection and some other things around visual communication and visual AI, Azure might have a better place for you, and easier sets of tools. And I'm not pitting one cloud provider over another. What I'm illustrating is it is a multi-cloud, because the truth is everybody has those use cases throughout their environment, whether they're a public sector customer or an enterprise customer.
Well, I'm glad you brought up the different clouds have different capabilities. And that's one thing that at Intel we have a huge bench of cloud solution architects that all they do is look at optimizing workloads, different types of workloads, based off of the different capabilities in the different clouds. So that's a great tool that we are now leveraging with our customers to come in and help them make decisions around multi-cloud architectures, around where should my data reside, in the cloud, on the edge, in my data center. There's lots of opportunities for some great architectures, and also some great mistakes. And we've seen them all. We've even made a lot of them ourselves. So we can help out wherever we can. So, hey, Gretchen, thank you for coming on the show today. Dr. Scott, Anna, thank you too.
Thank you, Darren. It's really a pleasure to have a chance to talk about all of this. And as you said, there's so much more to cover. So this will be the first of many, right?
Yes, absolutely. Look forward to these 2 on the podcast often, and we'll let everyone know when you guys are on.
Thank you so much.
Thanks, Darren.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.